All right, here I am coming to you from my humble house talking about exponential growth and decay. So let's just jump right in. This says an element with a mass of 780 grams decays at 17.1% per minute. How much of the element is remaining after 19 minutes? So again, remember our basic exponential function is y equals ab to the x, where a is an initial value and b is a rate, right? It's because we're raising b to a power, which means every unit of time, whether it's minutes or hours, we're going to multiply our initial value by that percent. So we're going to say, like, if we were doubling, we were going to multiply our initial value by 2 every single time. Well, in this case, we're decaying, and decaying means we're getting smaller. And so we start out with 100% of our element, right? With 780 grams. It's 100% of what we started with. And the next minute, we are 17.1% less than what we were before. So what is 17.1% less than that? Well, that means we have 100 minus 17.1%. Okay, so that would be 82.9%. So every minute, instead of having 100% of what we have, we now have 82.9% of what we had the minute before. So our rate is 82.9%, but remember we write it as a decimal. So we're going to move that decimal place over 2. So we have y equals, now our initial value was 780, so we do 780 times our rate, which is 0.829, to the x. So this is our general function, and I know lots of you like to skip right into just putting in the time, and that's fine, but you have to remember that there is a general solution that just gives us kind of like a basic, we could put in any time and get it out. So then this is going to be our time. So we're going to put in 19 minutes for that. So we have y equals 780 times 0.829 to the 19th. And get out my handy dandy calculator. 0.829 to the 19th times 780. Now you're going to be tempted to multiply that 780 by the 0.829 first. Don't do it, because remember, exponents are more powerful than multiplication. So exponents happen first. That's they override that, like we talk about. It's like divorcing and marrying, right? So like exponents are like they're all married together, and like the multiplying is just you're dating, and so it's like marriage is more strong. Okay, that was a really bad example, but you get what I'm saying. Okay, so that's going to give us 22.112. Remember, we go to 3 decimal places in precalculus, so 22.112 grams is left after 19 minutes. So this is actually decaying pretty fast. Okay, so this is what we're talking about. We're writing an exponential function given 2 points. There's a delta math that's open. It's due Thursday at 4 p.m. You will have time on Wednesday to work on it during class. All right. So let's just remember how to do exponential functions. So we have a town, it's a population of 14,000 people. It grows 3% every year. What's the population going to be after 6 years? So again, y equals our initial, which is 14,000, times our rate, which is 1.03, because we have 100% of the people plus another 3%. So we have 103% of what we started with every year. So if I start out with 14,000 people, the next year I have 103% of that. And then whatever that is, then I have 103% of that. So I'm going to do 1.03 to the 6th times 14,000. And that is 16,716.732. And remember, though, we don't report people in decimals because that doesn't make any sense. So either, and I really honestly don't care, you either report this as 16,716 or 16,717. Round up or down, it doesn't matter, but do not report fractions of people. Okay, so if we have a new car that's purchased for 22,300, we're going to depreciate it because new cars depreciate. We're going to find out the value after 6 years. So we have y equals our initial amount. And then how much is that car worth after the first year? It's worth not 100%, right? It was worth 100% at the beginning. Now it's worth 10.25% less than that. So what is 100 minus 10.2? Well, that's 89.75. Let's make sure that that my tired brain isn't taking over. Yeah, I got it. 0.8975. Okay, and then that's to the x because we have x years. Now we go ahead and put in 6 there. So we're going to put in 6 for x. We're going to do that to the 6th times 22,300. Oops. You know what I did? I didn't put my 89.75 as a decimal in my calculator, so I got something with 16 places. That doesn't make sense, right? You get this huge number and you're like, if your number doesn't make sense, don't report it. Go back and check, okay? So I got 11,654.98, and since this is money, we're going to report it with 2 decimals because money has cents. So that's how much the car is worth after 6 years. Okay, but here's the deal. We're not usually given anything with a rate. Like in math class, we're like, here's the rate of change. And you know, like for interest and stuff, we're given a rate. But usually scientists have data, they calculate the data, they like figure out the data at one point, then they figure out the data at another point, and they have to figure out what the rate of change is themselves because like a lot of this stuff isn't known, okay? So what if we just have 2 different points on a graph and we have to find the rate ourselves? So this guy named Samuel, he invested $230 in an account in 1995. It grew exponentially and reached 270 in 1999. Determine the value of in the year 2009. So the super important thing here is that it grew exponentially. Lots of people, when we saw this question today, wanted to just say, oh, well, it grew $40 in 4 years. That means it grows $10 a year. And so they literally, like, they were screaming the answer, like, it's 370. And I was like, let's think about this, remember? Okay, so exponentially means that we're not adding a value every year. We're multiplying. So regular linear growth, right? We count by in this like adding sort of way. So it's like plus 10, plus 10, plus 10, plus 10, right? Okay, so that's how linear stuff is. Every year we just add 10, right? Okay, but what happens? What is exponential? What does exponential mean? Well, that's like times 1.5 times 1.5 times 1.5. So we like multiplied it by 1.5 every single year or something like that, right? So you can't just like divide it and be like, oh, because that's linear growth, and exponential growth doesn't work that way. It grows super fast. You know, it starts out slow and then it just like goes fast. So keyword is it says exponentially. Okay, so then we have y equals a b to the x is our function. Our initial value is 230 because that's where we started. So we're just going to say y equals 230 b to the x. And we still have that pesky b. We don't know what the rate is. But guess what we do know? We do know that in 1999 it was worth $270. That's a point on our function. At time equals 4, y value is 270, right? The amount we get out is 270. So we could plug this into our function to find b. So let's plug that in. at time equals 4 years, we had $270. Okay, so what we do is we divide both sides by 230. Whoopsie, there it is. I told you. My tired brain is getting the best of me. All right, 230. So we have b to the 4th equals 270 divided by 230. And I really got to make my calculator stop timing out. Okay, 230. So it's 1.173913. What I would do is just leave this in the calculator, okay? You get this number with all these decimals, leave it in the calculator because it calculated bits more than what you see. And you don't want to use a rounded value in exponentials because the more you round, like, 2.001 and 2.0011 exponentially could really change. They actually could be very different if you raise them each to the 50th power, right? So always just use the whole number. If you're using a graphing calculator, you can store any numbers. I'm happy to show you how to do that in class sometime. Okay, so you have 270 divided by 230 equals b to the 4th. Then we're going to take the 4th root of both sides to get b by itself, but a lot of times you don't know how to do 4th roots on a calculator. So remember, b to the 4th, how do we undo to the 4th? Well, what exponent could I raise this to that it would cancel out that 4? Well, remember, I could raise it to the 1/4 power because when we multiply those exponents together, these become 1, right? So this is just b. So in your calculator, you can do this. 270 divided by 230 to the 1/4. That's the easiest way to put it in your calculator. There's other ways. This is definitely the easiest. Okay, to the 1/4. I better put parentheses around that 1/4. Okay. So that I got 1.0409. So that's my rate of change. Okay, this is how much it's changing. This is my b value. Okay, so I can come back to my function and I can write y equals 230 b, which is 1.0409. Now again, I would store that value in your calculator. I wouldn't like just write down a rounded value, but store that. And so that's the rate that it's changing at about 4% a year, 4.1% a year, and to the x. Okay, so now the question asked, what's the value of the account in 2009? So that's going to be 14 years from when we started, right? So let's plug in 14 for this. And we've got y equals 230, 1.0409 to the 14th. And I'm going to take the number that's already in my calculator. I'm going to raise it to the 14th. I'm going to multiply it by 230. And we're going to get $403.14. So he's going to have $403.14. All right, so I'll be back for another video with some more examples.